have the limit as x approaches infinity of the tangent 1 over x squared. Okay, I want to demonstrate a problem that we have here where we've run out of properties. It looks as though we could say that the limit of the tangent function of 1 over x squared, that as x approaches infinity, that we can just put the limit on the angle. The problem is that you cannot transfer a limit outside of a trig function to the inside of a trig function on the angle. This cannot be done. You cannot, again, transfer from the outside of a trig function to the angle. Okay, so we need another method, and the method we're going to use is substitution. Okay, let's take a look at 1 over x squared. 1 over x squared, as we take the limit as x approaches infinity, this equals 0. Therefore, I'm going to let u represent 1 over x squared. If I let u represent 1 over x squared, then we can say that the limit of u as u goes to 0, okay, because this is u right here, and this is all going to 0. The limit of u as u goes to 0 is 0. Okay, so this is a nice substitution for us. And so let's go back and actually put it in. So we have here the limit as x approaches positive infinity of the tangent of 1 over x squared. This now becomes the limit of the tangent of u as u goes to 0. And there is a property that says if this is in the domain of the function, you may replace this into the function here for a value. And 0 is in the domain of the tangent function. So this becomes tangent of 0. And now we use this property to finally solve that tangent will be 0. Number 5. Once again, we run into the same problem. We can change this into the limit of x squared. As x goes into infinity. Limit of x squared as x goes into infinity times the limit of the tangent function of 1 over x, again as x goes to infinity. Well, this can be further solved because this can be an infinity right here. The problem with this again, we cannot transfer the limit from the trig function to its inner angle. So this is the part that kind of stops. So from there, I'm going to once again use substitution. I'm going to let u represent 1 over x so that if I take the limit of 1 over x as x goes to infinity, this will give me 0. Well, this also implies that the limit of u as u goes to 0 will be 0. Substitution. Okay, now I can put this in here, and we have the limit as x approaches infinity of x squared times the limit of the tangent of u as u approaches 0. Here, this will give me infinity, positive infinity, and this will give me the tangent of 0. And infinity times 0 is 0. We now have the limit as x goes to negative infinity of x squared minus 1 all over x minus 2. And again, we're going to multiply by the reciprocal of the x with the highest degree in the denominator, which is x to the first power, so we'll multiply by a 1 over x. Now, note, since my x is headed in the negative direction, 1 over x will remain constantly negative. So we're actually using negative numbers. These are all negative numbers. These are all negative numbers. So this will be a negative that we're multiplying by. So this will end up being 1 over x times x squared gives me negative x. And negative 1 over x times negative 1 gives me positive 1 over x. Distributing this, we got a negative times a positive here, and we end up with a negative 1. And a negative times a negative gives me positive 2 over x. Okay. Now let's begin the process of sending all of these to x into negative infinity. Let's see here. So we have a limit here of negative x plus the limit here of 1 over x, and then divided by the limit here of a negative 1, and plus the limit here of 2 over x. Okay. Now, for all of these, x is going back to negative infinity. So for negative x, the function negative x looks like this. As I go backwards, this guy goes up to positive infinity. Okay. And here, this is for the function 1 over x, which looks like this. As I go back to x is negative infinity, back this way, I'm using negative numbers. So all of this will be negative. Negative 0, or subtract 0. Okay, furthermore, this is a constant function of negative 1, so it just stays here at negative 1. So as I go to the left, this will remain negative 1. And here, the 2 over x has the same function, same look as this right here, 2 over x. And I am going to the left, so I'm going out to negative infinity. Sorry, I'm going out to 0, but I'm using negative numbers, but still it's 0. Okay, let's put all this together. I got positive infinity divided by a negative 1, which ends up being negative infinity. So it's unbounded, but going down.